Hi everyone, this is Infinity YouTube channel. Please remember to like, subscribe, and share. So today, I just want to summarize the proof of all the Laplace transform that we've done so far. So you try to make an adjustment in areas that you need adjustments on. Okay. So let's call this table of standard Laplace transform. Table of standard Laplace transform. So remember we did Laplace of many f of t's. So let's highlight our f of t. Let's highlight our f of x. Let's highlight our f of t. Let's highlight our f of s. Okay, so I believe it's going to be long. Let's see how it goes. Okay, so anytime you see f of x, okay, just a brief intro. When you say Laplace of f of t, okay, when you say Laplace of f of t, Laplace of f of t is equals to the integral of 0 to infinity exponent of minus st f of t dt. Okay, so this whole integral is equals to f of x. So anytime you see f of x, I'm trying to tell you the Laplace of f of t. Okay, let's go. So the first f of t that we did was a. So if a is f of t, what will be the f of s? Which means what will be the Laplace of the f of t? So we know that the value is a over s. Okay. The next one that we did was the Laplace of exponent of at. Exponent of at. What's the value of the Laplace of exponent of at? We have that it's actually 1 divided by s minus a. Now, in a situation that you have f of t as exponent of minus at, what will be the Laplace of exponent of minus at? The answer is going to give you 1 divided by s plus a. Next, the Laplace of tn, t raised to the power n. So what's the value of Laplace of t raised to the power n? The Laplace of t raised to the power n is going to give you n factorial divided by s raised to the power of n plus 1. Okay, that will be the value of the Laplace of t raised to the power of n. Now, the next one is the Laplace of cosh. The Laplace of cosh, that is when f of t is equals to cosh at, a hyperbolic function. So the value of cosh at is going to give us s divided by s squared minus a squared. Next, when f of t is equal to sinh at, so the value of the f of x becomes a divided by s squared minus a squared. Now, if f of t is equals to cos at, normal trig function, the value of f of s becomes s divided by x squared plus a squared. Okay, the difference between cos and cos is just the signs. Now the next is sin 80. So sin 80 is going to give us a divided by x squared plus a squared. Just the difference between the sine and the sinh is just the signs. So but there's one I want to add, and we are going to use it when we do a subsequent example, because you are going to use Laplace to solve differential equation. You can use Laplace to solve differential equation. You can use Laplace to solve simultaneous equation. You can use Laplace to solve so many type of equation. You can use it to solve Yes, I've said ODE. So let me give you when f of t is equals to an ODE type of equation, how we are going to represent it in f of x. So if an ODE, if you have f of t as y prime prime, okay, if you have it as y prime prime, or y prime prime is same thing as d squared y dx squared, okay, or you have it as okay, this is actually the main tool that we usually represent ODE with, okay. So if this is your f of t, the f of x will give you, how you're going to present your f of x is given by s squared y of s minus s y of 0 minus y prime of 0. Okay, don't worry, when we solve differential equation using Laplace transform, I'm going to show you how you can analyze this. So when you have another function like y prime, if you have like y prime, or let's say dy dx, dy dx is represented in Laplace. If you convert dy dx to Laplace, the Laplace of dy dx will give us s y of x minus y of 0. So this is the value of dy dx, the Laplace of dy dx. This is the value of this one, is the value of the Laplace of d squared y dx squared. This one is the Laplace of dy dx. Now if you want to find the Laplace of just y, or the Laplace of just y, if you want to find the Laplace of just y, you're just going to have y of s. So that's how to do it, okay. So I made it as short as possible, so I believe it was useful and helpful. So just go ahead to know all these Laplace, because you might need it in your subsequent questions on Laplace. So but before we go, I want us to do a simple example. Let's do a simple example. So you will try this example and you put your answer in the comment section. So let's say an exercise. Okay, what's the Laplace of t raised to the power 3? What's the Laplace of exponent of minus 3t? What's the Laplace of 2? What is the Laplace of cos 3t? What's the Laplace of sin 3t? What is the Laplace of cos t? And what is the Laplace of sine 5t? Okay, so do this and put it in your comment section. Thank you. I hope this was useful and helpful. Please remember to like, subscribe, and share.